Hey everybody,
Hey.
I hope you are doing your starter. The starter is number 7. That means tomorrow they're getting collected. Okay, here we go. It says use triangle ABC in the coordinate plane and dilate it. The center of dilation is the origin, so that means in the middle, by a scale factor of 2. So a scale factor of 2 means it's getting bigger than 1, so it means it's going to be a larger thing. So Mr. Nelson, break it down for us.
So we have a triangle ABC already there plotted for us. It is located at 1, 3, 5, 1, and 1, 1, as it's already given to you right here. All right, so we need to take this lovely triangle and multiply all the sides by 2 and then try to figure out where it fits. It's not too bad. It is a little confusing to do by hand though. So let me show you what that means. You'll notice that the height of this triangle is 2 and the base of this triangle.
The original.
Yep, this is the original, and so that's 2 by 4, right? It has a height of 2, base of 4. We're just going to multiply those by 2, the scale factor, which gives you a handy-dandy triangle that is 4 tall and 8 on the base.
Because 2 times 2 is 4, and 4 times 2 is 8. But where it's weird is that it doesn't just sit on top of the shape because it's not dilating. If it was dilating from point C,
then it would be right
good.
there.
But it's dilating from the origin. And so it also has to be twice as far from the origin.
Yep, and if you take a look right here, I'm gonna try zooming in actually, just so they can see that really quick. Maybe right there. This distance from the origin, which is our point of dilation, has a distance, like a diagonal distance of 1. We'll talk more about that diagonal distance later, right? That needs to double then, right? Times by 2. So that's where we are actually going to take our triangle. And instead of being right here, we need to double the distance away, which would be right there. And you can see the ordered pairs right here. For instance, A goes to,
A prime.
I guess we'll say A prime, which is at 2 comma
6, and we go to
B to B prime,
which is 10 comma 2, and C goes to 2 comma 2.
2, 2.
So if you pull that back in and we look at the whole thing, you're going to see there's a connection between 1 comma 3, 2 comma 6, 5 comma 1, and 10 comma 2, and 1, 1, and 2, 2. What do you think our scale factor is?
Our scale factor is 2.
And so everything was multiplied by 2. So if you have your yellow card, you better not throw it away because you need it. Pull your yellow card out, and on the back of the card, it should be blank. Some of you are doodlers, but on the back of your yellow card, on the back, I want you to write down dilation rules. So hit pause, write this down, and then we can move on and I'll explain to you. So 3, 2, 1. Hopefully you press pause. You realize that if we're going too fast, you can always hit pause, rewind, and watch again.
Yep, again, we can do this by hand. We don't need the graph anymore. If I have the points, just now I know the scale factor is 2, means multiply all the points by 2. 2 times 1 is 2, 2 times 3 is 6, 2 times 5 is 10, 2 times 1 is 2, 2 times 1 is 2, 2 times 1 is 2.
Time out. Let's take a step back, Mr. Nelson. I don't know what the heck you're talking about. Well, what Mr. Nelson just did there super fast, and he's correct, is that he took this scale factor. This rule says the original is xy, and my rule is k times x and k times y. Now, that k knows, when we did the lateral moves and the horizontal moves, we used n and m because they couldn't be the same. But when we are dilating something, everything has to be dilated by the same scale factor. So whatever that scale factor is, what we're multiplying each point by. In this case, the scale factor was 2. That's why Mr. Nelson took the points, multiplied by 2. And so the way that would be written out if we were writing the rule between here and here is we took this original one, x comma y, and we said, okay, we're going to take this and multiply 2 times the x, and we're going to multiply 2 times the y. And that's how he got each one of those points. So
sounds good.
Now, when we graph that, that's 2, 2, 6 is way up here, 2, 2 is right here, and 2, 10 is here, and we made the same triangle without all the work. All we had to do is write down the rules.
Yep.
Cool.
Rules make things fast.
Today we're going to be using those rules to do the dilations. If you understand that it's kx, ky, which means whatever your scale factor, be it bigger or smaller, whatever your scale factor is, you have to multiply your x and your y by it. So let's get straight into it. Jump right down. All right, go ahead.
Yeah, so Noe learns to program graphics on his computer. He draws ABC. First, he reflects it across the x-axis. up, to form triangle A prime, B prime, C prime, and then he dilates that image with a scale factor of 1/2, so it gets smaller. The center of dilation is still the origin, and the final image is A double prime, B double prime, C double
Because we're
prime.
making
Two transformations.
Okay, so if we're going to do this, the first transformation, we did it really quick by hand. We're not going to spend a lot of time. This because we're going to teach you how to do it with the
I'm going to
rules.
give you kind of like the visual real fast. First thing, reflect across the x-axis. That would put it somewhere around, oh no, they didn't give me enough room to draw it, right?
But we know that because it is a flip, we know that it's congruent because anything that's a rigid transformation stays congruent.
So we're still congruent. We haven't dilated, so we're still congruent. And then we're going to dilate by a scale factor of 1/2, which means this triangle's gonna, all the sides are gonna get shrunk by 1/2, right?
To the origin, though, not to a corner,
Yep.
but
so
to
that's
the
actually,
origin.
it's gonna end up like bringing this in by 1/2, and then all the other points in by 1/2, and you're gonna have a smaller triangle. I'm not being perfect here. We're just getting the concept. I can see that it's all gonna be in the first quadrant. That tells me things about all of the ordered pairs. X, Y's should all be positive.
So this is where rules come in handy. So on the next slide, we have for you, and this should be on in your book on page 100. So it shows you all the points: 2, -2, 6, -2, 4, -6. Those are the original points. So I like to do is write down the rule. The first thing we did is a reflection over the x-axis. And what's the rule for that? Oh yeah, x-axis, x stays the same, y's changed, so we go x, -y. That doesn't mean everything turns negative. It means it goes to the opposite. And so if you look from origin to the after reflection, if we go back and forth between them, you'll see that we took 2 stayed the same, but -2, the opposite is +2. 6 stayed the same, opposite of -2 is +2. 4 stayed the same, opposite of -6 is +6.
Yeah.
Now, the second part is a dilation. This time it's a dilation of 1/2, which means our shape should be getting smaller.
Yep.
The rule for that, again, is kx, yx. In this case,
Right there, right here.
k is 1/2. So we're going to replace.
So this is the kx, ky is like the general rule. The rule that we're given, though, is that the scale factor is 1/2. So you can't put kx, ky for the rule.
Because that's not enough information.
It's going to be 1/2 times x and 1/2 times y.
So we take our point that was after the reflection and 2 and multiply each of those by 1/2. Well, half of 2 is 1 and half of 2 is 1. Half of 6 is 3 and half of 2 is 1. Half of 4 is 2 and half of 6 is 3. And now we have the new point. Now, look at the next picture here. It's really cool now. We can obviously see our reflection from here to there, and these are the points that we got for that first pie diagram, and these are the points of the new. There's that 1, 1, there's that 2, 3, and there's that 3, 1. And so we're able to see that really quickly. But so again, I can see that from here to here, this is a rigid transformation. That's going to be congruent because it's the same shape and size. But from here to here, is it congruent?
Not anymore.
No.
Not the same
It's
size.
Similar.
Same shape.
But it's not the same size.
That's right.
So moving on, again, we're going fast, and you can always pause and go back if you need to.
And those questions are going to be coming up here. So triangle A prime, B prime, C prime. That is this one right here, right? That's the one we're looking at. Is that triangle similar to our original ABC?
But it's congruent. Yes, but what we said in the last or 2 lessons ago, we said that you can go congruent is also similar, but not everything that's similar is congruent.
So because they are congruent, they are also
Similar.
So that's a yes on this one. They are similar because they are congruent.
I would prefer congruent, but we
Yeah.
can say that they are similar.
Next part of that question, is the double prime similar to the single prime?
So that's after the dilation.
So is that our smaller one and this one right here? Are those similar?
And again, we know they are because one was a dilation of the other. So they're the same shape but different sizes. Now those two aren't congruent, obviously, because they're not the same sizes.
So those two are similar, but they're not congruent. Is the double prime then similar to our original ABC?
And the answer is
Yes.
yes. Why? Because we got our prime from the original, and that was congruent, and now that one's similar. So yes, they're all connected. They are
right.
all similar. Moving on.
All right, this one, there is a mistake being made. Grace wants to rotate PQRS, that's your blue shape there, 90 degrees clockwise around the origin to form the P prime, Q prime, R prime, S prime.
Yep.
Yep. Then she wants to dilate the image using a scale factor of 2 at the and the center of dilation being the origin again to form the double primes.
And this is where I love to use my little yellow piece of paper that you should have written your rules down, kx, comma, yx. So that's your dilation rule. Okay, so I like to take that shape and I say, okay, the first thing it's asking me to do is a rotation of 90 degrees clockwise. Clockwise is righty-tighty. So I like to take my shape and turn it so that I can see how it ends up. So you see how it's there, it ends up there, and that's the shape there. And then I just make sure when I label it, so I have my finger on Q, turn it, Q should be in the bottom right corner, R should be in the bottom left corner, and so on and so forth.
So it looks like that rotation is good. She has rotated it there.
Clockwise there.
It's clockwise
Beautiful.
90 degrees. That's perfect rotation.
And the next thing says she wants to make a image, says scale factor of 2. 2 is bigger than 1, so the shape should be bigger. Well, I see a bigger shape here, but I see a problem.
There's a problem here because when we dilate, we don't go back to if we're doing a sequence of transformations, we don't dilate the original image if that's our second transformation in the sequence. So rotation takes us from this shape here to this shape here. If we're going to dilate that image, we need to dilate this one, not this one. And it looks to me that Grace has dilated the original out to get our bigger shape. It looks like she's dilated the original correctly, but she should have dilated.
It's like we're putting on our shoes. First we have to put on our socks, then we put on our shoes.
Yeah.
We put on our socks and then we put on our shoes. We don't put on our socks, then take off our socks and then put on our shoes.
Right.
That's weird. So
So this, technically, we should have dilated this one, and I'll just kind of give a quick sketch of what that may have looked like. It should have been probably around here and bigger. That's kind of where it should have been. It's off my page and it's off yours as well. That's where it should have gone.
What mistake did she make? She dilated the wrong shape. She dilated the original and not the image. Hence the prime. Okay.
Right.
So these are one of those questions. I love these ones where you have to kind of use our logic. So I'm going to try to go through this with you and sort of help you keep your logic in mind. It says 2 transformations are performed on triangle X in the coordinate plane. First, X is rotated 90 degrees counterclockwise. Okay, anytime we do a rotation, we already know that is congruent. It's a rigid transformation, so I already know that's going to be congruent. Okay, around the origin. Cool. To form triangle X prime. And so what I did here is I sort of made you sort of pretend. So I took this and I rotated this counterclockwise to here. Not perfect, but just sort of give you an idea so you can kind of think about it in your head. Those are congruent, correct?
Yes.
Then X prime, which is the new image, is dilated using a scale factor of 3/4. 3/4 is smaller than 1, so it's getting smaller. And right off the bat, when I see a dilation, I know dilations are not congruent. They are similar. And so my example here, as I sort of showed you, getting it smaller. So this one was rotated to this, which was dilated to this. So then it says the center of dilation, which statements about X and X prime is true? Is X similar to X prime? Is X similar to this? And the answer is yes. Why? Because this is congruent to this and this is similar to this, therefore this is similar to that. So I could say check, A is a go. Cool. Next, X is congruent to X prime. Well, X is congruent to prime, but prime is a dilation, which we just said is similar. So this is a big niet. We get a big cross it out. You are wrong. Okay. Next, triangle X is both congruent and similar to X.
We just said it's not congruent.
No, we know that this part right here is not true, so this whole statement can't. You can't just take what you want. You have to take the whole statement. And then finally, neither X triangle X is neither congruent nor similar to X prime. We know it's similar, so right off the bat, because we know it's similar, it can't be neither. So again, that is also wrong. So the only answer that worked was similar. Cool beans.
A.
Moving on.
Moving on up. Down.
Moving on up.
All right, Dario dilates the triangle JKL in the coordinate plane using a scale factor of 0.5 or 1/2 and a center of dilation at the origin. That means it's going to get smaller. That's right. He labels the image J prime, K prime, L prime. Then he translates the image 3 units up.
So here is what we think is best for you. Anytime you have a dilation, you need to go right to the coordinates, because the best way to do the coordinates is by a dilation. I mean, by just using the rule. So instead of doing that and then doing it by doing it on the graph, we're just going to go ahead and write down the original ordered pairs and go from there. So my first ordered pair, if we're taking at J, it looks like J is at -6, +4. And looks like K to me is at 2, 8. And it looks to me like L is at 2, -4. So I now have that, and now above that, I'm going to write that first rule. And that first rule I'm going to write, so that's original is XY, that's my original, and my dilation means K times X and K times Y. But in this case, we're replacing the K with 0.5, which is the same as a half. Does it matter? No. Some people find that easier to put in a calculator.
I'm going to write 1/2 if you don't mind.
But if you put it in your calculator as 0.5,
Same thing.
That's fine. And so we're literally just taking what's half of -6, -3. What's half of 4? Okay, so to get there, we're just going to multiply -6 times 1/2, because that's the scale factor. That gives me -3. And we're going to multiply 4, which is our y, times 1/2, which gives me 2. We're going to multiply 2 times 1/2, which gives me half. And we're going to give 8 times 1/2, which gives me 4. We're going to give 2 times 1/2, which gives me 1. And we're going to take -4 times 1/2 and gives -2. Again, if you did that as by 0.5 in your calculator, it's the same thing. It can go either way. So now I have that new point. And now I need to do another transition on it. The next transition I'm going to do, or translation or transformation, I should say, more specifics, is I'm going to J prime prime, and it wants me to take the image 3 units up. So I look to myself, I know that's rigid. Is it a translate, a reflect, or a turn, or a rotate? I'm going to go with it's a slide or translation, and up is in the Y direction. So my rule is going to be parentheses X, Y, and in this case, because we're going up 3, is going to be +3. So now I go to my primes there, and J prime, and I'm just going to, X stays the same, so it's -3, and Y is 2 + 3 ends up being 5. 1 stays the same, and 4 + 3 ends up being 7, and 1 stays the same, and -2 + 3 gives me 1. So if I want to graph this now, I can easily go about doing that. So we're going to go to J prime, which is -3, 2. We're going to go to K prime, which is 1, 4. We're going to go to L prime, which is 1, -2, and draw the line. And you can see that would have been really hard to try to figure out where those points go without actually taking the ordered pair. Now, to go to prime prime, which is our shift up, we're going to go for J. We're just going to go up 2. And that's going to be there. And at that point, we can kind of cheat. But if we know, it's going to be up 3, not 2. And that's going to be at -3, 5. The next one's going to be at 1, 7, which is up 3 from where it was at. And the next one's going to be at 1, 1, which is 3 up from it's at. And there is our new shape. And by doing it with the points, as opposed to by doing it with the ordered pairs, it says, instead of using the pictures, it ends up being a lot easier. So we're going to try to do another one of those. We're going to be going to the practice now on page 103. You really should try it, and then we can go over it. If you're just waiting to just copy it down from what we say, then you don't know what you don't know. So you should do it, but now we're going to go over it because we're going to assume you've paused and done it. Here we go,
Yep.
Mr. Nelson. Break it down to me.
Ronnie dilates the ABCD to form the prime ABCD. She uses a scale factor of 3/4, so it should be getting smaller.
Okay.
And then she translates up 7 units. I'm going to go through all the rules again.
Okay, so we got to go A, B, C, D, and we're going to get those points. I'm going to yell them out to Mr. Nelson so he can write them down. A is at -4, -4. B looks like it's at 8, -4. C looks like it's at 8, -8.
Good.
And D looks like it's at -4, -8. So that's the important part. You have to be able to look at those points and be able to see where they're at. And now the first thing it asks us to do is a scale factor of 3/4. So I'm just going to go ahead and write X, Y over the original. And now, Mr. Nelson, we're going to add the rule to the top, which is going to be, instead of K, we're going to replace K with 3/4 X and 3/4 Y. And that's where it's really helpful to have
a handy-dandy
calculator.
calculator.
I got me a calculator. So I take my calculator and turn it on my calculator, and I'm going to multiply each one of those. So -4 times
3/4.
3/4.
-1.
And that gives me a -3.
Oh, see, I was wrong.
See, that's what calculators are for. Next one is
Same
the next
thing?
one will be the same thing, and then
-3.
and then 8 times 3/4.
2.
I'm guessing so.
6.
It's going to be 6. Boom.
It's +6.
+6.
And then we have a -4 again. So
which
that's
we already
probably
know that one equals -3. And we already know that 8 times is 6.
6 and then -6.
-6. And then we already have 4 because we've already done that multiplication. That's going to be -3. And we're going to have, again, -6. So now I have the dilation. But now I have to do one more move. It's going to go up 7 units. Again, up 7 units is a translation, and that means the y is changing because we're not going left or right. So the rule for that would be x, because it doesn't change.
And y.
And then y,
plus,
and we're going up 7, so +7.
+7.
And so we're just going to take those points, and
we'll keep the x's on all of them, and then we'll add 7 to the y values. -3 plus 7 is 4. For b double prime, we'll keep the x value, which is 6. -3 plus 7. Well, let me think. That's 4 again. C double prime is keep the x, which is 6. -6 plus 7 is 1. And then D double prime, we'll keep the x value. -6 plus 7 is 1.
6, 7, 6, 7. All right, so now we have both cases. We could actually draw that shape if we wanted to on there. You can too. But we have the right answer. Moving on to 12. We're moving on. All right, 12. Now, this is, again, drawing shapes like this are really hard, especially when we're dilating, because there's no straight sides on the actual grid that helps us out. So what I'm talking about here is it's hard to make this change if I'm multiplying this by a scale factor. This is where points are super important, because we need to be able to go, okay, here's a point here. Here's a point here, here's a point here, here's a point here, and I can call that A, B, C, and D, and labeling them helps me do these transformations, which I wouldn't be able to do without it. So I'm going to label the side A, B, C, D, so I can do that, and then we're going to read this question, and I'll show you what I'm talking about.
Yeah, so Cyrus plans are designed to paint on his bass drum. He starts with figure P that we have here, translates it 3 units to the right, and then to form figure P prime. Then he reflects P prime across the y-axis, which is going to flip left and right, and to form P double prime. Then Cyrus dilates that using a scale factor of 2, which is going to make it bigger to get P triple prime.
So we're doing 3 things here. My goodness.
Yeah, so we're probably going to do this pretty quickly and speed up the video. So if you need to pause it.
So the first couple moves should be really quick, but we're going to speed the video really quick for you, and we're just going to write down the points. So I'm looking at it. A is at the point -6, 6.
-6, 6.
B is at the point -4, 2. C is at the point -5, 3. D is at the point -7.
Yeah.
1. All right, and so our first transformation, transformation is of unit 3 to the right. 3 to the right is when we move the x, not the y, so it'll be x plus 3, comma y. And we're going to go ahead and do that to each move, so that's going to become -3, comma 6. Next one's going to be -1, comma 2. Next one's going to be -2, comma 3. And next one's going to be -4, comma 1. That's our first translation. Our next translation, which is going to be our prime, is a reflection across the y-axis. That is, the y-axis is this one, so we're going from here to here. That's where y stays the same, x changes, so we're going to go parentheses -x, comma y.
So that's going to take our -3 and turn it to positive. We'll keep the 6. It's going to take our -1, change it to 1, comma 2. Our -2 will go to +2, and we'll keep the 3. And lastly, for D double prime, we'll go to +4, comma 1.
And then finally, what we really wanted to get to, which is the dilation. A dilation is when we do k times x and y times x. In this case, our multiplication is 2, which makes it bigger, so it's going to be 2x 2y. And then I'm going to take
Oh my
each
gosh.
one of those points and write them down.
So we're going
Ready?
to times by 2, which is going to be 6 12. So 6, and then 6 times 2 is 12. Our B triple prime, holy cow. 1 times 2 is 2, 2
cow
times
with
2 is
holes in
4.
it.
A lot of holes. There's a lot of holes in my, it feels like there's a lot of holes in my hand right now. So we're going to multiply this one by 2.
4 6.
So 4 6. Wow, this is a horrible font to choose. And then D triple prime is going to be 8,
2.
comma 2 if we multiply those. Wow.
And now I could graph each one of those and get to where I want to, but you can see why
Whew.
knowing the rule and knowing the ordered pair makes life a lot easier.
Yeah. Next. All right, this one's not too bad. In fact, we only have 1 point to do this to now.
This is page 104, by the way.
Yep, triangle EFG is translated 3 units to the left, and then the image is dilated by a scale factor of 1/2 or 0.5 to form E double prime, F double prime, G double prime. The center of dilation is the origin. Vertex E is located at 5, another color, that's fine, 5 comma 6.
So because we're doing
Negative 6, fix that for me.
Negative 6. That's my E.
That's E.
Then we're going to be changing that to E prime.
Blop, blop.
And we're going to be changing that to
E double prime.
prime prime.
Blop, blop.
We're going to be changing that to E
That's all.
triple prime.
Nope, just double.
That was a test. You failed.
Yep, only 2 in here. We're going to translate and then dilate.
Okay, so what are we doing in the first one, Mr. Nelson?
First thing we're doing is we're going to be translating 3 units to the left, which means that's going to affect the x value. And because it's moving to the left, let me get that up here. We're going to take x, y, and that's going to take it to. Translation to the left is going to be x minus, and it's by 3 units, comma y. We don't touch the y value. And then the next thing after that is we are going to do the scale factor of 1/2 or 0.5. So it's going to be 1/2 times x, 1/2 times
And
y.
yes, you can use 0.5 as your scale factor.
Yes,
It's fine.
0.5 is the same thing, same
So
number.
now that I've written the rules, all I got to do is apply the point that it gave me and use the rules.
So the first rule we have is x minus 3. So 5 minus 3 is 2. And we leave the y alone, negative 6. And now we're going to multiply both of those by 1/2 to do our dilation. 2 times 1/2 is 1, and negative 6 times 1/2 is a negative 3.
So because we only did it to 1 point, it was pretty simple. Rules, points, blah.
Yeah.
All right, I think that, we got one more.
What?
Yes, we got
Oh.
one more. Here we go.
I thought I was
You
done.
can do it. We can do it.
get-
You can do it on the boat. Now, who's got a boat? I don't know. All right. Indira uses an app to add a photo to a photo gift for her dad. She rotates the photo, then she dilates the image using a scale factor of 3, and the center of dilation is the origin. Tell us whether each statement is true or false.
True or
And so
false.
what I like to do first is look at what we're doing here. The first thing we're doing is a rotation. I know rotations are congruent because they are rigid. But
Which
then
means they're also similar.
but then
they're
I'm
congruent.
doing a dilation, and a dilation we talked about not being congruent. It's similar, but not congruent. So let's use that to try to answer these questions. It says the original photo is congruent to the final image. Well, this, if it was just a rotation, it would be, but because the dilation is not, this is a false statement.
Yeah, they would be similar, but not congruent.
Correct. The original photo is congruent to the rotation. Well, we said rotation is a rigid transformation.
Yep.
So that statement is actually true. The original photo is similar to the rotated photo.
Tricky one.
That's tricky, but remember we talked about with the square, with squares, you can go backwards, but you can't always go forward. So something can be congruent and similar, but it can't necessarily be.
Yep. Congruent does imply that it's similar. It's just more specific.
Since the original photo is been rotated, yes, it's more specifically it would be rigid, but since we can also use similar, that is a true statement, just a trick one. And then finally, the original photo is similar to the final image, and that is a also true statement because yes, this first one was rigid, this one is just similar, but that together makes it just a true statement. So that completes your assignment for today. Hopefully you can do the homework now, which is on using dilations, that k times x, k times y, to solve your problems. Scratch a piece of paper, calculator, and your life should be easy.
Yep.
See you soon, I hope.
See ya, bye.
Ciao.